In this video, we're going to go over modularity. We're going to discuss what is modularity and why is it necessary as we work on our 3D assets for games and game environments. We're going to briefly talk about modularity for characters just because it's good to know about kind of what each discipline is. But for the video, we're going to go over what exactly is modularity for things like props and environments, and in small cases, materials. We're going to demo inside of Maya and Unreal Engine how to set up environments and props for hard surface as well as for organic setups with texel density. So with that being said, let's get started. So what exactly is modularity? Modularity is a design principle that helps us break down complex systems into smaller, self-contained little units or modules that can be easily assembled, rearranged, replaced, moved around, however you want to discuss it. It enhances efficiency by making everything more of an individual part that can be modified or upgraded without actually changing the whole of the environment or the whole of the system. It's flexible, scalable, and very easy to maintain. Now, modularity for 3D art, again, goes over a lot of that, but the idea is that we want to try and use modularity because it helps us speed up production, it's consistent, it allows us to iterate and faster, and it is better supported for things like memory and content scalability. Especially with Unreal Engine, we can actually use modularity for things like static mesh assets, material instances, functions, material layers, even for some instances of modular character setups. In some of the previous videos we had talked about for performance, there are things that we have to worry about like VRAM or GPU costs. By using modularity, it helps us actually cut down on things like draw calls. It also helps make sure that we're maintaining, for many different disciplines, better workflows and better techniques in our authoring content with our DCCs. Now, modularity in games is different. Basically, the idea is that instead of you having to make a whole building, like a church or a skyscraper, you actually build using kits or smaller modular pieces. We want to think about using that versus having to build everything by scratch. And the reason why is there are three main different areas that we actually use modularity across for all disciplines. The first, of course, is breaking down larger complex assets. Now, like many of you, I've had a hard time looking at a single large thing like a church and how do I break it up into like much smaller pieces. And if you think about it as just the whole of the church, you're probably like, oh man, I have to recreate this stuff over and over and over again. But that's not the case, because if you research what you're working on and see that there might be some repetitive or repeated features, then you can probably make just those repeated features and then copy them over or modify them and move them over. Thus, instead of having to make everything by scratch every single time, you can iterate a lot faster. And that goes into the second thing of modular pieces. By taking a large single asset and breaking it down to these smaller modular pieces, we can easily reassemble and make iterations very, very quickly. We could take the church and then make small steeples. We can probably make other bits of architecture or add new wings or new sections of these buildings because they all maintain a similar and consistent art style. Think of it like IKEA furniture. Like a lot of IKEA parts, there are many similar parts that can be reused for different things, like tables, chairs, any other type of furniture. They use similar things like similar bolts or similar structural pieces. You can reuse them down the line and not have to have the cost of having to make something new completely from scratch. It's a lot faster because you've already made it essentially. Now, the third is performance, and we talked a little bit about it before with VRAM and GPU cost. The idea being is that one, draw calls, which is a part of like the GPU, is going to be a lot lower because instead of having to make an asset one time, it had to be drawn once, or having to make a bunch of uniquely made assets once, you can make window, wall, door, whatever piece you want to call them. You draw them one time, but when you make duplicates of them, or when you make instances of them, better yet, you can actually relieve on that cost of draw calls because you've already had the instance of where the GPU is being called from the CPU to draw that geometry with that material. because it's already been referenced once, the draw call doesn't simulate again. It's going to reuse that same computation, thus making it cheaper because you've already called on how to draw the window, the door, the wall, all those different things. The other is based off of this thing called culling. Culling essentially is where when you have something drawn on screen, when it's not referenced in the camera's Fulcrum view, it can be taken out of the rendering pipeline and saved off in a cache or pool, essentially, to be re-referenced again when you turn around and look at it again. But the problem is that when you have a large asset like a church, big building or something, if you even have a single pixel of that one singular large church, it's going to reference the entire church. And say that church might be 100,000 triangles. That whole 100,000 triangles, even being at the most tiniest view in frame, it's still going to reference the entire thing. Now, if you use modular pieces, it's going to actually cull all the modular parts that are just completely not in frame. But for whatever modular piece that is still in frame with those singular pixels in the camera view, those will be drawn. So instead of you having to reference the entire 100,000 triangles, you're only going to probably reference the small fraction of the geometry that is actually referenced. The other maybe 80 to 90% of the 100,000 triangles, because they're modular, are just going to be culled off until you actually can see it fully in view. That's one of the reasons why we want to think about modularity as a whole based off of some of these three different principles. Now, here's some examples of modularity with environments. We have a couple singular rock assets, some group assets, and then again, just the overall in general scene. And you can see you've made something like this that feels very unique, very organic, but again, just using very similar reusable pipelines. That's what you want to think about. Now, like I had mentioned early on in the video, we're going to talk a little about modular characters, but we're going to put a focus more on the environment and prop side of things. But there's modularity for characters. The idea being that you can reuse similar assets, similar body types, similar heads. You can even try and reuse similar skeletons for animation. There's a lot of different workflows that you can go into for characters. I highly recommend looking at things like how Bungie or how most games that have modular customizable characters handle things, because for things like Bungie, for Destiny, you have essentially 3 different character types with 2 different variants, aka the male and female versions of the Warlock, Hunter, and Titan class. They all have similar versions of the geometry, but they're rescaled a little bit, but they all share similar animations because they have emotes and other kind of programmable actions. So because they have similar skeletons and similar proportions, even though they're completely different armor types, they all can reuse a lot of the same animations because they try to keep things very consistent and modular overall. So that's one thing I wanted to kind of quickly bring up for characters, just because it's something that we could take a whole video on to talk about, because it's not just about animation or how things are handled inside of Unreal Engine, but even in the DCC, inside of the programs that you use, some people tend to actually have a similar, maybe low poly head or body parts, and then just use that low poly asset to then bake from a bunch of different types of heads. There's a whole thing from the Uncharted Naughty Dog character team where they actually would scan heads from different people that actually work at the studio, and they would modify the high poly head that has a bit of albedo already on there to fit with a kind of modular Nathan Drake like head. And then when they would bake it, it would have a lot of the same properties from the high poly of the scanned head that they would bring in, and the albedo. And then they would just make some small modifications, whether it's some ZBrush work or some paint overs with some albedo, and they would have a completely different character just from some simple raw scans that they modified just a little bit. So that's something that we can actually even do a full video on later on, but I just wanted to quickly go over it. And same thing with modular materials. It's definitely something we're going to go over in a later video, especially when I go over things like material layering. If you're curious about material layering, I've also done a video with Beyond Extent. I can link it in the description, but a lot of materials nowadays are fairly modular as long as you're using tilables as your baseline. These characters were made a lot with tilables, so a lot of the fabrics, a lot of the leathers, things like that were tileable materials. The only thing that was uniquely made or baked was the normal map in AO map for the sculpt of the character itself. Everything else is uniquely textured with tileables in a layering format inside of Unreal Engine, not inside of, say, Substance Painter. Now, for modular environments, just like I had talked about with the idea that you build out singular pieces and then take those singular pieces and kind of build them out as modules to build an entire scene. That's what you want to think about. When you look at your scene, you want to break down from reference, from what the idea is and what the scope is, and start to think about, okay, I'm at least going to need a door, a simple wall, little things like that. And you want to think about scale. How large is this going to be? And you want to think about how to fit this all on a grid, because when you look at this, yeah, it's a hallway, so it's going to have a similar kind of box shape. It's going to feel very inorganic. But we need to think about this because there's going to be things we're going to add on extra, other props, other materials, shader effects, things that we can add in that can help make this scene feel very much not modular, as in not like noticeably repetitive, because that's one big problem with modular environments, is that they can feel repetitive very, very easily. So we need to find different smart ways like vertex paint to help break up some of those noticeable repetitions for things. It's just like when you have a tileable texture on a very large surface and you can see that repetition over and over again. We need to hide the repetition using different modules. And as you can see here, they have many different variations, floating variations for the top trims, the wall trims, the rails, everything like that. And again, they thought ahead where they need to have all this stuff. So when you can think ahead, you can take something that seems very complex and break it down to its much smaller pieces, almost like you're working on a Lego set and you're just working on some of the more smaller single Lego bricks that will then end up becoming a Plants Lego set or some Mario Lego set or something. That's kind of what you want to think about how you approach this. Props is very similar too. Now, this one is, again, hard surface as well, but pipes are actually a very hard thing to do sometimes for some folks. They feel like when you're working on a scene like this, that you have to make everything bespoke or essentially unique every single time. But pipes are a very modular system as well. You can go to any hardware store and see that there are very similar pieces. Straight, T, cross joints, splits, many different types of assets. And so by breaking these things down into much smaller pieces, you can then recreate them. Say in a game production, you have a certain layout of a scene or a certain layout of a building. And then maybe halfway through production, something changes. You have to scale down the project. And if you made all that stuff uniquely inside of like Maya or Blender or somewhere else, well, you got to now take so much more time to refit all of that into the scene again. Whereas if you built them into smaller pieces modularly like this, guess what? You don't have to go into Maya or Max or wherever you're using the DCC for. You can just take all the modular pieces that you've made and then just refit them again inside of Unreal Engine. This way that it's still non-destructive, it's reusable, and it's a lot faster to make iterations from. And you can even make small variations where you can maybe scale some of this stuff down, swap out some of the textures, and reuse some of the exact same pieces. Like this guy and this guy use the same pieces. Again, they're just scaled in a much smaller format. So it's very easy to reproduce this stuff and make variations very, very quickly. Now, just like I mentioned before, materials themselves are modular. Even textures can be modular as well. The idea is that when you make your materials or when you texture your assets, try not to texture them as much inside of a outside program from your engine, like Substance Painter, Quixel Mixer, Modo, whatever you're going to use, and try to find ways to texture them inside of the engine using tileables and using some simple masks that you can generate from those programs like Modo or Painter. This allows you to have versatility. You can make variations, as in a lot of these guys use very similar properties, whether it's an albedo color change or a roughness adjustment to make things shinier or rougher. You can retile stuff. There's many different ways of versatility that you can actually apply to this stuff and save so much more time. Many game studios are trying to use more of this workflow, especially with these newer generations of games. Like an example from my time with Naughty Dog and The Last of Us Part 1, that game relied heavily on tilables, where we can use tilables on some of the architecture, some of the weapons, some of, many different assets that require a wood tileable asset. But because it's reusable, we save so much more on time and efficiency because we didn't have to go into Substance Painter and do all the texturing that way. We can just make a reusable, tileable texture, and we can easily throw that on top of other stuff and then layer other tileable assets together to make it feel unique, even though it was not a unique asset. It just relied heavily on tilables and how we blended those tilables together. This is that mentality you want to think about. It can be one thing to do work on a gun and texture inside of Substance Painter. It's another thing to take that gun and find ways to make it modular, whether it's the parts themselves or from the materials themselves. This is something you want to think about because many studios are moving in this kind of a direction versus making everything bespoke or one-off assets nowadays, because it's not that cheap anymore. So now that we're inside of Maya, let's quickly go about how we would set up Maya for creating our different modular assets. And the first thing is we need to set up scale more than anything else. Just like with textile density and one of the previous videos, scale is going to be a key thing in our approach. Now we're also going to go over some textile density stuff too, so just bear in mind that we are going to revisit that. So the first thing we want to do is go into our settings, go to preferences. And again, we need to make sure that we're using centimeters as our working units inside of Maya. Unreal Engine also uses centimeters as their working units as well. A lot of it has to do with the fact that if we were to say switch to meters, meters are singular large, numbers. The problem is that half the assets that we might be using, whether they're weapons or just small props, are going to be well under that. So it might be better to work within whole asset numbers like 17 centimeters versus 0.17 centimeters, like in the decimal system. Even though it's a decimal, we will typically try and stick to centimeters. It's a lot easier to understand. 100 centimeters, 1 meter. Now, once you got that, let's go into our display and change our grid settings. Now, my grid settings are already set up how I want them to be, but the idea is that you want to change your units to however wide you want them to be, say 400, 500 units. 400 units, aka 4 meters, is pretty good. Then you would want every unit to be maybe 20 units, aka 20 centimeters. So in this case, if I have like a square, one of these squares is going to fit a 20 centimeters by 20 centimeters. So something not too crazy. And the last one is the axes. The axes are your cardinal directions of X and Y on the 2D aspect of it. The 3D aspect, there's no real third axis on Maya, at least for a 2D plane, but I still want to know where the axis is. And typically it's usually kind of gray like this, and that doesn't pop out as much as you would want. So I like to keep my axes at a very annoying color like a red, just because it pops out a lot better than if you were to use that dark gray color. And also green can be a little annoying to my eyes. So this red works well. But once you apply all that, you're good to hop in here. Now, the first thing I always end up doing when I bring this in is I like to bring in a human scale character reference if I am ever working on a prop or even some environment modular kits. The reason being is when we work in games, we also have human scale references. And for the most part, most human scale references are typically about 180 to 185 centimeters. That's close to about 6 feet tall for folks that know Imperial, or 5'10", 5'11"-ish or so. But it's on average close to that because that's what the typical hero character averages to be the height of. But we bring one of those characters in. I like to add a unlit material, so a surface shader with a kind of less than 50% gray, so it just leaves a nice silhouette to view on, because it's not about their details. I rather just focus on how tall they are in comparison to what I'm working on, essentially. The other thing I like to do is I'll add a box in here, and as I make the box, here, let me go to here, I'll set the box's width to 100 on every degree, because I need to reference a 1 meter by 1 meter asset. Now, for this guy, I'm going to set the box up in a way so I'm going to move the pivots, which that's also something we're going to go over a lot. So if you hold D on the keyboard for Maya, it allows you to start to move this pivot, because by default, the pivot's always going to be at the center of whatever your mesh is. So D will allow you to move it. And if you hold X or V, it'll allow you to snap on a certain other type of aspect. So V will be for vertice, X will be for grid. So for this case, I want this guy to be snapped to the bottom. Now, you can also actually, if you're holding D, you can actually highlight over an edge, a vertice, or a face and align exactly with that. So if I hit this, it'll align exactly on the bottom in the middle of this polygon face. And once you got that, you can now hold X and you can snap it to the grid, just like this. Now, next, what we want to do is we want to make a material, or if we already have it, apply a material of texel density to our box. So I've already brought one in, and it looks like this here in the UV editor. Now, the problem is that when we look at this to this, the texel density is completely off. And we need to make sure that our texel density matches to the proper scale, aka every single one of these faces on this cube is 1 meter by 1 meter in dimensions. So we need to change that. And the easiest thing to note is one of these UV tiles will fit an entire 1 meter by 1 meter dimension of data. So all you gotta do is rescale one of these faces to match that. Or we just go to transform, go to our texel density checker, set our map size to 512, because that's what the texel density for us is, 512 per meter, or 5.12 units per centimeter. So in this case, we already have that, so let's hit set. And now we just need to snap into the grid. So if you hold X, again, it'll snap the grids here inside of the UV editor as well. And as you can see, now we have a consistent 1 meter scale size for everything. Now we are good to use this for reference. That's what we want to do. So how do we actually approach making modular pieces? And that comes down to reference. You know, whatever type of environment you're working in, you want to try and, mimic something like that. So I was able to look at some quick reference because this video was inspired by one of the comments. Chili Gaming had talked about how to do UV circular complex pieces like St. Paul's Cathedral. So if we pull out St. Paul's Cathedral, we see it has a lot of this kind of rotunda Greek Roman type of architecture. And thankfully, it is fairly modular. The idea being is that you want to take this, and sometimes what I like to do is I'll save it, bring it into Photoshop, and from there, I will actually highlight areas that I know that are going to be repetitive. So we'll quickly hop into Photoshop and I'll show you what I mean. Okay, so now that we have our reference, we have in Photoshop, let's figure out what we need to do. Now, the big and easy of modularity is looking at what is repeated at least more than once. So in our case, a lot of the actual dome may not necessarily be needed, as in like we could make one whole dome piece if we want to. Like that is totally useful. But seeing as how there's something else here that might be similar in size or similar in dimensions to this, we might be able to recreate this guy. So what you could do is, and what I like to do is I'll go in here and add a new layer. Let's find a color that we like a red. And what I'll do is I'll actually just kind of paint on top of this guy and make a very kind of rudimentary shape. And this is how I can start to plan out what I might need inside of my modular kits. So once I have something kind of like this, I'll go in here and just quickly fill the gap. And I like to change the opacity to something low, like this, like where you can still see it's like somewhat red. Well, guess what? Now I can go over here and there is like a small like rotunda here as well, or something that could be modified close to it. We could probably even think about planting something close there. So let's use that same red. Now the other thing is like these windows, like this window and this window are exactly the same as that one as well too. So if we go into a new layer, I'll grab another one like a blue. And in this case, I'll just quickly grab the window and however big it is and just kind of highlight over it. And then do the same thing here. Again, I'm being very rough. Like, you don't have to be as refined as you want, but just enough to say that we can find noticeable repetitive pieces. And again, do the same thing, just lower the opacity down. And if you see that something is repeating over again from the same thing, just change the color and swap it back. So this is how we typically plan this stuff. It looks like this area right here has these two flat kind of columns, and these two flat columns are repeated on here, 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 in a lot of areas. So that's another color that we can swap into. So let's do some green. So let's just grab this. Do the same thing here. And for the most part, this is how most folks typically tend to plan out, like looking for repeated architecture, because this will help us make things a lot easier. Same thing right here as well. So we can keep that nice and simple. So for, say, this guy, we may, because it's a round, reusable, like rotunda, that's what the shape is. You probably can make half of it or even a quarter of it because it's a hemisphere. But for, say, something like, here, let me do pink. Let's grab this guy. I think this guy right here, you can make one of him because it looks like he's being reused over and over again. So the thing is, you have to make one of them, but you're going to have to find out probably on average how many there are going to be. So you're going to have to kind of eyeball and try and test it out a little bit. So thankfully you can test this stuff out inside of Maya as well. But then there's like maybe just a few more things, like these pillars are also being reused as well. And in some cases, besides the pillars, there's this other kind of circular inset. So we can also point out like, hey, maybe this inset is also something that we can work on as well, because he is being reused over and over and over again. So again, little things like that. Go through this planning phase, take some time to look at your reference and try and gather as much as you can. Again, whatever is repetitive, try to, see if you can reuse it in smart ways. Like even also here, all of this is trim that is using the same exact details, even though some stick out more than others. This is all the same exact modular kind of like built-in trim. So we can actually use something like this. Same thing even up here where there is this like block section that's being reused for these corners and like some of these other inner corners and outer corners. But then there is another that's like just these like little pillar trims. Like these guys fill in most of the other gaps on here. So that might be like another thing to work on next. So again, find what you can to make things repetitive. And from what it looks like, most materials are either somewhat large segment blocks, bricks, or even just standard concrete. So those are even like the textures that you want to try and find and reuse where you can. And then, hey, guess what? Look at how things can be modular. Let me grab that cyan color again, because guess what? The same pillars up here can also be reused down here as well. So this is the idea of how modularity can be brought into full use. So think about how small you can get this and then try and recreate it as best as you can. So let's hop back into Maya and maybe let's try and do that little rotunda real quickly. So the rotunda seemed very large, so we can do a hemisphere like this. Now the hemisphere, we can have however many faces we want here. Typically you want to keep the kind of subdivisions in a power of 4, because you want this guy to still have kind of 4 equal quadrants, because you want a, not just a hemisphere, but even like a half of a hemisphere, which is like just a single corner. So 20 is good. 32 would be better. So if we do 32, that means we'll have 8 segments per corner, or you can even do 40. Again, just play around with how you want your silhouette to be. Silhouette is always a key thing. And if you're ever curious how you want to like render silhouettes, A little fun trick I like to use is in Maya, where if you hit the numbers 1 through 7 actually will turn on or off certain visual components. Like 1 shows wireframe, 2 shows wireframe plus a secondary wireframe for quick smooth preview. 3 shows full smooth preview. 4 shows wireframe. 5 shows the mesh without any textures on there. 6 shows the material that if you have a one applied with like textures, and then 7 shows what the scene looks like with lighting applied. But if you don't have lighting, it just renders it black. And with it being rendered black, you can actually effectively see how well the silhouette is. And if you feel like you have enough going here, like if we go back to this guy, if I change him to 32 again, let's see, does the silhouette look pretty good too? Yes. So maybe we don't even need those extra 8 segments per height and horizon. So we're good with this. So go back to 6 and only use what you need to. Geometry can be a little bit cheaper than textures, but just know to model towards the silhouette versus feeling like you have to make everything like super like low poly than you need it to be. So for something like this guy, I can quickly just double click and delete that segment, and boom, now we got ourselves a hemisphere. But again, we're not just working towards a hemisphere. Here, let's go to the top view. We probably want a single corner. So let's go in here and select just 1/2 and then 1 other half. And guess what? Now you've made it perfect. Because guess what? If you do all your texturing, your UVing with this one guy, guess what? You can easily duplicate him inside of Unreal Engine, and you can rotate him like so. And then as long as you worry about how you want the pivot point to be, or like where specifically, as long as you can snap the pivot point, you can easily recreate this guy like so. So these are things you want to think about. Now for the other part, aka how do we make the little segments, those little squares and stuff? Well, that can actually easily be recreated as well. You just got to take this and try and make one. So if I extrude this and bring them down, guess what? I can easily grab this polygon face and I can use, where is it? Detach, which will allow me to disconnect it from the rest. And then if I do separate, then this guy becomes his own geometry. Now, the only thing you just got to do is make them flat like this. And now you can easily take this and actually make something very similar to these like other little kind of square shapes and stuff. And if you make one of them, then guess what? If you at least move him over like so, you can snap him and move him and rotate him. And then easily remake that piece over and over and over again. You just have to also kind of figure out what's like the proper rotation angle on there. So in this case, the idea probably would be is divide 32 by 360 degrees, and that'll give you the amount of degrees you need, which might be very close to 5 degrees, give or take, 5 degrees and some change. So that's part of the whole modular stuff and how you could approach something similar to this. But let me just hide some of these guys because we need to get back into actually making some standard wall pieces. So how we approach making modular kits comes down to scale and size. The big idea is that you shouldn't always feel like you have to make like a single 1 meter asset. Like if you make a 1 meter by 1 meter wall, you don't have to build everything out of that 1 meter wall. If you have very large walls, you can easily do a 2 meter by 2 meter wall, just because it'd be easier to do. Because look, if we grab another box and let's make a 1 meter modular piece. So we'll go into this guy and we'll set the width and the height to 100, just like this. And for depth, which is your thickness, you typically would probably want to do at least 20 to 25 centimeters, because if you were to bring this into, say, Unreal Engine, you need to have at least a certain amount of thickness. If not, Lumen actually has a hard time with very thin bits of geometry. So you typically might want to have some of your modular pieces be a little bit thicker like this. You don't have to see the thickness from the sides, because you can always make the kits only be seen from the front and not from like the sides like this. So it's really kind of up to you, but we could do something kind of like this. So we have this guy as our starting modular piece. But when I actually want to move him around, guess what? If I duplicate him and I hold V to snap, he only snaps to the middle of the object, because we've not messed around with the actual pivot point of the object. Pivot point is going to be key for your modular piece. Whether it's a modular wall or architecture, or even some modular prop pieces like those pipes and stuff that we were talking about. So just like how we kind of had set up the pivot point change for this guy, we need to do so here as well. So let's hold D and use V to snap him, maybe to the side at least, so that he's not having the pivot point snap to the middle like this. So if I hold D now and I hold V separately, not at the same time, now when I make a duplicate and snap him, he snaps to the side. But what if I want to, duplicate him again? And then what if I want to make like start turning him, like start to make like the next wall? Well, I don't like any sort of weird Z fighting if I don't have to. Like, I don't like this where they're like overlapping like this. It's just not good. And also, if I need to, he's again in the middle of the thickness of each object. So it's probably not best to have our pivot point be in the middle here as well. So maybe we already moved him to the side. So maybe let's move him to the front like so. So let's hold D and V and move him to the front. That way, when I duplicate him like so, he still snaps. But then when I do a rotation to, go to the next corner, it's not making any sort of weird Z fighting at all, which is perfect to what I want. There's one problem though, and that is when I want to bring this guy inside of, say, Unreal Engine is going to use this pivot point where essentially the ground is going to connect to this object. And right now, if I were to drag him in, he's going to drag like this. And that's not what I want, because he's like halfway through basically. So how do I want to approach this next? Well, we've already moved our pivot point in 2 different directions already. Maybe why don't we connect the pivot point to the bottom of the object, so that when I do this now, when he gets dragged in, because again, he's going to get dragged in and placed on whatever ground surface at the pivot point's level. So if I do that, he's going to hit this ground like this, like that. Exactly. So this shows exactly for most kind of architectural pieces like walls, windows, and doors, how we want to set up the pivot point for. Always typically on the left or the right, essentially the ends of the geometry, into the front of the object, and at the bottom of the object. So bottom left front corner, or right bottom front corner. It's really up to you. Typically we do left because we do left to right, just like how when we read left to the right. So in doing so, it'll allow you to move like this, rotate them around, and again, they all snap exactly to the ground where they're supposed to be. Perfect. But just like I had mentioned, it might be a hassle when you have a 1 meter by 1 meter square doing this, and you have like 9, 12, 15, like a bunch of individual pieces. Like this can be a pain to have to deal with. So maybe instead of this, we could do something maybe a little bit easier. Here, let me do 16. So what if I want to, like, how would I reduce this? Well, that's very easy. You just take this guy and you scale him up 2 times. So because he was already 1 meter, if I scale him up times 2, at least on the X and the Y, he's going to now be a 2 meter by 2 meter wall piece. Now, again, thickness is the same, 0.2 or 0.25. But as you can see now, instead of me having to very, quickly, like if I need to, I can do this with just, instead of 1, I just do 3. So there's 1, 2, and 3. Instead of having to use 12, like that's a lot to have to deal with. So This allows me a lot more speed because I don't have to use individual small pieces like this. So think about how you can effectively like simplify your geometry where you can. You can have a 1 meter square for whatever you need to, like a floor or something. You can also do a 2 meter. You can even also not just do a square shape, but even do half of a square shape, like a rectangle shape. Like if you need to do a kind of more long strip like this, you can also do this as well. It's kind of up to you on how you want to approach it. So this is like another option that could go as well. The smart, good idea about this is that essentially, if we look at the textures on these guys, we want to make sure that they are seamless. Now, right now, texture-wise, there's nothing on them. So here, let me swap these textures to the texel density. But oh no, the texel density is wrong on every single one of them. So let's quickly go into each one of these guys and let's fix them. So the easiest thing is just going in here to modify and first doing an unfold so that it re-unfolds everything to the proper dimensions. Then what we can do is from our modify, we'll do an orient shell, which will snap the rotations to the closest 90 degrees. And then now let's just grab the UV shell so we can separate all these guys. Okay, so it looks like we have all of them here. Now let's quickly set the texel density. Now they're all at the same consistent texel density, but let me just quickly fix some things on here, because what's happening is each one of these guys flips kind of upside down, more or less. Like this face flips upside down compared to this face, creating a upside down texture. And maybe we don't want that necessarily if we do end up seeing the backside. So what we could do is if we grab each one of these edge loops here, we can split the edge and have the faces right here. And now what's cool is we can actually flip them around. So if we go here to modify, we can do flip, and you can flip horizontally or vertically. We're going to do vertical. So we'll hit apply, and guess what? Now we go to the back. Now they are right side up. They're still the wrong face, but let's go to the horizontal part and now hit apply. And now they're the same exact dimensions. They're now mirrored from the back. So we got this. And now we can quickly grab the other edges and move them and sew them like this. That way we can now grab each one of these guys and do a stack shell. And what stack shell does is going to grab the geometry right here and try and stack them as best they can without trying to rescale or re-rotate them. So stack shell. And then we got one more. So modify, stack shell. So now we effectively have all of our pieces. Let's just make one small change, which is we need to make sure that the edges of these guys all end at a texture UV tile border. Because if not, we're going to have a problem with keeping this thing seamless. So for this guy, very easy, because again, this square shape is actually 1 full meter on both dimensions. So if you just hold X, we'll just snap him right here in the middle. And guess what? End to end, perfect. This guy, we need to make sure that he also does something similar. So let's do this. And as you can see, because even though he's 2 meters tall, he still is 1 meter and 1 meter. So his is going to be in the middle of one of these tiles, but he is at the middle between the first and the second square, being perfectly seamless. Just like how, even though this guy is 2 meters by 2 meters, his pivot point is going to be exactly in the middle between 2 full 1 meter squares, like this. So now that we have our UVs adjusted, let's see how it looks. So let's snap them together. And bingo, seamless, no issues. That's what you want to have for this. So as long as you have your edges here to here, always in between with one of these kind of middle gray, like axes lines, you're going to be perfectly fine and make sure, everything's seamless. The other thing you want to make note of, by the way, is because there's going to be some times where maybe you need something larger than 2 meters. You can go up to 4 meters, but note that every time that you make a new dimension, you have to make sure the scales are within a power of 2 kind of methodology, aka 1 meter, 2 meter, 4 meter, and 8 meter. We might not even go beyond 8, but the idea being is that, guess what? You can combine 2 1 meters into a 2 meter, 2 2 meters into a 4 meter, and 2 4 meters into an 8 meter, or even 4 2 meters into an 8 meter. They all are divisible and they all can be easily snapped together without having weird odd numbers. So that's what you want to think about as you approach this. Because the next thing is going to be, well, we have a wall, but what about doors? What about windows? How does that work exactly? Well, that's where you have to use the human scale reference, and we need to make sure that we can consistently make sure that we can make a wall or window shape out of one of these modular pieces. So if we use this 2 meter by 2 meter, let's make a doorway simply. So for the doorway, all you got to do is take this guy. Let me just quickly duplicate him. And I need to grab the middle point because I like to use the middle point because I can split it down the middle using a bevel. So I can have equidistant parallel edge loops to use as like my frames for my door. So if I go to, here, let me go my custom one. I'll grab the multi-cut tool. So the multi-cut tool allows you to start at a vertice and cut through an edge loop. Well, if you hold shift, you can actually snap right to the middle, and that little black dot right there, that's the exact middle of that edge loop. So you can quickly do this and go right down the middle every single time, thus making a perfectly middle edge loop. Now, what I can do is I could take this and I can grab a bevel, and that bevel will always make a equidistant edge loop from each other without needing a middle one. So if I were to grab my guy, here, let me just duplicate him. And I'm going to try and put him close to the middle. Let's see how good this looks like size-wise. If it feels maybe a little too wide, then let's just go right here to the sides and go to that poly bevel that we had just put on there. And let's change the fraction to maybe 0.45. So if it's good, maybe 0.4. Just, you know, kind of eyeball it and feel. If not, if you really want to see a size-wise, like, you can always measure your doorways to try and make things a little bit easier. But one thing to note is level design, or even just, you know, 3D designers in games typically will actually make your doorways a little bit larger than it's supposed to be, because when a player goes through it, or a player with a camera, or even just, again, for camera's sake, goes through a doorway, it feels a little claustrophobic. So they might modify the doors just a tiny bit to fit a little bit better when you're going through those. So they make the door a tiny bit wider, which is, again, totally fine. But now we can add a new edge loop to make our top. Like that. And then what's cool is I can select all these guys, or at least even just select these guys. Select the same sides here. And let's make a new bevel. And I now have a frame. So if I change the fragment on it, now I have a door frame that I can use, equidistant. So if I delete face, face, and face, now I can just as easily recreate a doorway. So I can just select all of these edges, extrude them from the edge, and then just hold V to snap. And hey, there we go. Now there's might be some things I need to modify, like, you know, maybe this might not be the most copacetic, so let's try and fix this. So let's move him here. Let's move him here. And let's move these little vertices here, here, and here. Let me merge my vertices. And of course I know, guess what? UVs are going to be a little funky. It's totally fine. bridge the gap, or here, let me bridge polygon here, bridge a polygon here. And then, oh, let me also do one more thing. Let me fix, hold V to snap him equilateral so that it's like making a nice straight line. Because I don't like having weird, odd lines like this. I'd rather have them be perfectly distanced from each other. But guess what? Now I got to fix this. So I'll delete history real quickly. And let me just quickly re-UV this guy. Which you can just easily go create. Oh, sorry. Let me grab all the faces. Create automatic. Now I can easily grab this, which is my backside. And I'll select all of them and set the textile density first. Make sure that I got this right things. Yes. So as my front, what I like to do is I actually like to make sure that I have all the stuff on the edges selected. So here to here, cut, move, and sew, like so. Now let's do cut, move, and sew, cut, move, and sew. Let's do the bottoms, cut, move, and sew. And now all I have left are these guys. These are the inner faces. And how these guys work is I'm going to do a cut, move, and sew, but I'm going to use cut, move, and sew and not connect the inner corners, aka these edges right here, because I want to make sure that the texture actually repeats and is seamless across the edges. Just because, God forbid, if I throw like a brick texture on there, I want it to kind of continue around like how it's supposed to. And also because I'm using a tileable, I can have overlapping UVs. So it makes things a lot easier to work with. Just like how I can grab these guys and I can do stack shell. And it snaps them exactly where they're supposed to be. And again, he's a 2 meter by 2 meter asset. So just holding X allows me to snap him right here because he's going to be right in the middle. And now guess what? I have my doorway that has a little space if I want to extrude that out to make a little door trim. But I can easily just grab this and snap him over and boom. Perfectly seamless. Exactly how I want. You can do something similar for a window as well. It's just that instead of it connecting the bottom, you can do the top. So we can do the same thing here. This way, actually, it's easy. I just got to grab this and then do a extrusion, but I don't extrude. I just shape. So I make him just a tiny bit wide like that, and then choose how high I want him to be. If I want him to be kind of closer to my legs or closer up here, I can. I just delete. And then I'll do an extrusion. And then next thing I just got to do is make sure that he is still using all the textile density material. He is, which is good. So now let me just quickly merge my vertices. Oh, I messed up. Sorry. Here, let me go backwards. Yeah, not delete the faces just yet. Now select these guys and do the same thing and create a trim around the edges, a border, if you will. So let's do a bevel. And I need to, of course, make some changes to the bevel because it's beveling way too far out. So let's change the fragment size to something kind of closer to what I want. So maybe 0.075. Perfect, exactly. So now, delete. So we have something exactly like this. And then I'll grab a create automatic. And it looks like his size is still pretty good. So let's do set textile density size proper. And let's find, there's my front. This is my back. So let me just rotate him real quickly and see what we're working with. Yep, perfect. So guess what? Let's cut, move, and so. Sorry, cut, move, and so. Though I don't like that it's doing that, so maybe I need to unfold these guys. So let's do create automatic one more time, modify, unfold. There we go. So it looks like the unfold was not getting the proper size. So we also just delete history. Try that one more time. Modify, unfold. Okay, we're good. So there's my front. Let's do cut, move, and so. Okay, it's still acting up. So let's see about that with the text lens. Now, hopefully that should be good. So let's do cut, move, and so. There we go. See, no more issues. Cut, move, and so. So I want to make sure everything's straight. No weird distortions for UVs. So cut, move, and so. Cut, move, and so. Cut, move, and so. And one more. And then now, grab this guy. Rotate him. Select the UV shells. Modify, stack shells. And then move him exactly right there. And guess what? We are good to use all of these guys for our little modular pieces. They have the proper pivot points, they have the proper textile density, and they have the proper size and consistency so that there's no weird texture seams at all. So these guys are almost ready to go. We just need to do some due diligence, aka we need to now change the names of them, because I know as artists we tend to kind of forego cleaning up our outliner, but we need to, because think about as a team of artists, how would you feel if you're given all these assets that have like no real names to them or naming conventions to them? So we want to make sure that we're consistent and we work as a team to make sure that the next person who gets these assets has a proper name for them. So we'll start off with this. So this guy's giving me a wall piece, so we'll call it wall underscore, and this is where typically every studio has a little thing of like, do you add an A or a letter or a number or whatever behind the wall? Like maybe there's a variation of the wall or something. You can do so. But in this case, we'll just do wall and then underscore the dimensions, the size of the wall itself. And we start off with length and then width, just like with everything else in the world. So length is going to be 200 centimeters, not 2 for 2 meters, centimeters, because we might have stuff that might have some sort of weird arbitrary thing. So just one thing to note. So 200 underscore 200. That way we know, because this is a square shape. Then we have doorway underscore 200 underscore 200. Then we have this, which is also a wall, but this wall is 100. Sorry, he's actually, no, 200 because it's length, which is the height. And then width is 100. So 200 by 100. This is window 200 by 200. And then this, we could call it a wall. We could even call it a floor if we want to. We'll just go with wall for now. So wall 100 by 100. So now we have all our modular pieces. Now let's get this into Unreal Engine and see how we're working with. So got our pivot point right here. Let me just delete these old ones. And yeah, delete history. Everything's all good. So let's go in here and export selection. Let's go to this little Midcentury folder I have. And I've already made a couple, but I'll export this guy out. And when you export, the only things you need are two different geometry options. Smoothing groups, which are the hard and soft edges of the mesh, and tangents and binormals, which is kind of how the faces are actually rendering, not just how hard soft edges are, but if there's any sort of special type of tangent or binormal or even custom face weighted normals, you want at least these two guys to work. Most of these others we don't necessarily need, not even smoothing groups or triangles, because in Unreal Engine it'll actually triangulate for you. So once you got that, turn off embed media, that way you don't bring in any extra textures that you don't need for your scene as well. And now we just hit export. So we'll do that, and then let's go into Unreal Engine next and see where this guy goes. So now that we have Unreal Engine open, let's quickly go and import the wall asset that we had just made. So let's go in here, and here is our wall 200 by 200 wall mesh. Let's hit open. And now, mostly the only thing you have to worry about typically for this, and I like to do, is go into your materials, make sure you turn off import materials, turn off import textures, because you might not want to bring in any extra material assets from Maya that it might encode in there. It might be better just to bring your own materials made inside of Unreal Engine later on. So I usually turn those off. The other one typically is things like nanites. I turn off build nanites so that I can just bring the asset in just as it is. So once you have that, hit import and we'll bring him in. And let's quickly check on him. So let's drag him in and let's see what's going on. And ooh, see, this is where we have a problem. So just like how I mentioned before, pivot point is key for your assets. This is an issue with pivot point. Typically, when you are exporting outside of Maya, you have to make sure that the asset typically is exported at origin at 0, 0, 0. If you don't, it will be a problem and you'll have that where the pivot point won't match where it is on the mesh. So you have to make sure you typically bring that here, and usually for every other asset too. So usually just grab them, bring them right to the middle, and you're good to go. But if you were like me, you're probably like, I don't like having these assets all like in one small center area. So there actually is an option you can actually use to export this asset out without having to bring it all the way manually to the origin. And that is if you go to File, Game Exporter. What Game Exporter does is it allows you to quickly select an object, and typically you might want to go to export selection instead of all or object selects, because if you do export all, it grabs all 3D meshes and exports them all together as one single FBX, which is not what we want. So export selected, again, tangents, binormals, and smoothing groups for your geometry. That's what you want. But now let's go into the settings here, and there's an option you need to make sure that is checked, which is move to origin. And what this will do is on export, it will quickly move the object to origin at 0, 0, and then export it out and then move it right back to where it was. That's what you want. So once you got that, you want to give it a name, which typically you might want to put the, wall 200 by 200, whatever the name is. I like to also add a little suffix at the end for underscore mesh so that I know that this is a 3D mesh to use. And then when I'm ready, I'll hit export. And since I already have it there, I'll replace it. And now, when we go into Unreal Engine, guess what? If I just quickly go to where the mesh is and hit re-import, there he is. And there he is at origin. Perfect. So now that we have our asset in here, let's go over things like snapping grids, just because you want to make sure you understand how the grid stuff works. So just like in Maya, there's a grid here inside of Unreal Engine. You can see it here on the ground. You can hold G, or you click G a couple times. You can turn it on or off if you want to. It also turns off most of the other UI in Unreal. But as you can see, there actually is a couple of these options right here. When these are blue, they will show that they are snapping. And this one right here is grid snapping for movement, for rotation, and for scale. You can choose how many units you want to snap for. So maybe every 5 units, 10, 50, or 100. It's up to you. Typically, 10 is usually good for me. So choose 10. And then if you want to, you can see how it's snapping. See how it snaps per every grid line. That's what you want. If you don't want that, you just want to kind of manually place it wherever without it, you just click this and see how it's gray now. It will now turn off without any sort of grid snapping. So let's go back here. And now if you just, hold Alt to duplicate your object like this, guess what? It's going to grid snap. And now with the rotation, it also grid snaps as well every 10 degrees. And easy peasy. Do this, do the same thing as well. You can grid snap as much as you want. Now, again, keep an eye on your pivot points, because not every object is going to need your pivot point to be here. Say if we go back into Maya and maybe we want one of those little columns or pillars, just like we had worked on before, or that we were working on with St. Paul's Cathedral. For a column or a pillar, typically these guys will have a pivot point at the bottom because they need to snap to the ground, just like how they are, because they're objects that are placed on the ground. So if you grab this, you can see he's going to snap here. But since he's a pillar, you probably want to not have your pivot point on the side, but in the middle. That way, when you rotate him, he can rotate however he wants down the middle. So that is what you want. So there's no need to put into the front or the side. Just make sure that he's at least in the center of gravity, but at the bottom so that he can still snap to the ground when he's dragged in to Unreal Engine. So those are those options. You just got to think about how when you drag it in from the content browser inside of Unreal Engine, how would you want it to be set up? And that is how this works. So the last thing I want to go over on the hard surface side of things is some basic props. So things like pipes. So just like how we talked about with the columns, you probably want to rotate this guy like so, and we'll use him as my example column, or my example pipe. So let's make a little segment here, and let's quickly just select these faces, hold shift, select again, so I can do an inverse selection and delete the inside. Then let's do an extrusion, and I'll do an extrusion from the inside. Here, sorry, I grabbed the wrong cursor. And now I'm extruding from the inside. So when we do it on the inside instead of the outside, typically Maya doesn't like that. So what it does is it creates this darkness. And this darkness is a computer graphics thing to tell you that your geometry, the topology, has been flipped and inverted, which means that we need to actually go up to Mesh Display and hit Reverse. And that will reverse the polygons to be facing the right way. Now, the last thing I will do for this guy at the very least is I'm going to do one more extrusion. And then I'm going to make a little extrusion on both sides here. That way, when I do one more extrusion, it has those little lips like a pipe does. And how this guy is going to typically work is exactly just like how the columns were. So he's going to look like this. Because guess what? You still want to have the pipe rotate however you want along its axis, but still you want to be able to snap from end to end like this. If you have another pipe, like say, here, let me change the pivot point to the middle. Say we might have like a T-joint or a cross joint like this. It might be good to have your pivot point, again, still be right there. Just so that he can always snap, and then guess what? He can rotate where he needs to be. Probably rotate like this, and not some other weird way. So little things like that is how you would want to approach things like hard surface assets. Have the pivot point in a way where you know you can rotate it along its kind of center of gravity of sorts, but also so that it can be snapped to another piece relatively easily. Always check this stuff out and try and test it here inside of Maya instead of just only doing your testing inside of Unreal Engine. If you can do some nice simple snapping like how we did here, how you can quickly snap a lot of these guys together and see how they look, that's what you want. So this is how you handle modularity for hard surface assets. So I wanted to quickly go over organic modeling. So modularity isn't just for hard surface stuff, aka like snapping walls, doorways, things like that. There's also some organic modularity as well too. And so here I have a couple assets. These are just some low poly assets from Fab. And you can see here I have, a couple of these guys which are kind of single-sided like rock piles. And then I have like this boulder. Now, typically how modularity can work for things like this is, you might have a set of rocks, and those rocks are part of a certain type of biome. This biome could be, again, anything. Games like Sony Santa Monica's God of War have like the realms. Destiny has alien races as well as alien planets, and each one of them have a certain type of biome or a certain type of look and vibe to them that you want to dictate to. So typically, the assets that you're going to be working with are most likely going to be a part of a similar biome. But typically, you would probably reuse a bunch of these guys together. You're not going to make all the rock formations as one single thing because that's just not feasible. So what we're going to do is we're going to move some of these guys around and we're going to rotate these rocks so that we can try and reuse what we can. because we're going to try and actually make little kind of organic rock formations or rock shapes to use. And typically, we will usually get a block out type of scene, made out of very simple geometry like rocks and stuff, or even just like simple boxes or cubes and spheres, so that we can try and create some simple organic looking shapes. And when we get to those, we have to try and kind of create using what we already have. So typically these assets are going to use similar tileables. They're going to probably be set up with the proper textile density, and they might also have some sort of bake to them, like a baked AO or a baked normal map applied as well. But by having textures that are similar, like say if I grab all of these guys and I just apply the textile density check to them, they all will look a lot more consistent because they're using a similar texture. But again, using the large shapes first will create, again, the large formations. But the large formations are not the only things we're going to have to worry about. Now, the other thing you want to think about when you're working on this is that as I'm working on this, I am not actually scaling. I'm only doing movements and rotations. And that's because if I scale one of these guys, guess what? The textile density is going to be off, as you can see by the fact that the squares here are much different than here. We don't want that. So typically you want to keep the textile density kind of matching closer. And in order to do so, you need to make sure that you're using the proper textile density and just not doing any sort of scales for your operations. So we can very easily make some nice looking formations. It just depends on how we try to move these guys in certain ways. Again, there's also other things that you can do typically to help make this feel more natural. We have these guys, which are little bits of rocks that you can kind of place here. You can kind of move them a little bit so they inset inside of the ground. But these little rocks are going to help make it feel more natural. And because if they use similar textures, they're going to blend in a lot better typically. Now, I don't have a rock texture, but this should look a lot more natural if we had the same granite rock or dirt. And then we can also apply things like vertex paint on top to help apply similar dirt or similar cracks or similar just any type of lens like moss to make things feel so much more cohesive. So typically you would probably want to either make your own through things like ZBrush or photogrammetry and try to make sure that they have a similar shape language to them. Once you make one of them, make sure you set the UVs in a way so that they have the proper textile density. Like here, if I select all of these guys real quickly, this is what they'll look like when we actually have the proper textile density applied to them. There we go. Perfect. See, a lot more consistent looking, kind of matches a lot better. But the vertex painting, we can actually apply little variations of dirt in here to help kind of hide a lot of these seams. There are also other methods like pixel depth offset, which allow you to kind of soften or adjust, aka offset, the transition or the offsetting of the depth between two different objects, creating almost a fake soft blend between two objects. Now, some studios have also created little, what we call skirts or mesh-based decals that are softly blended with some opacity to help create a nice natural transition between two rocks. But it's a lot harder to do inside of, say, Unreal Engine from Maya because you have to think modularly and you can't use these uniquely made skirts as well. So trying to be smart where you can, but you can always use other shader effects to help create a nice soft transition between your objects. So that is how you would handle organic modeling. So the last thing I wanted to talk about was how we manage trims. Now, I want to go over in a different video on how we can approach authoring trims, but also in this case, how we can approach using trims. So here I have on a 1 meter by 1 meter plane a brick trim that I was able to create to use for various different things. Trims have really no big rule besides the fact that they should be typically tileable going at least left to right. And what I mean is, if I go about using an edge loop, say here, which separates this type of trim texture from, say, this little small secondary one, from this one right here, from this one right here, And then guess what? If I grab any one of these guys, even from like a UV standpoint, let me just quickly split the edges. So cut, split. Now I can grab one of these shells, and guess what happens when I move one of them? Here, let me just actually grab just the UVs. As you can see, when I move them, it's going to be perfectly seamless, no matter which one I go to. So that's the cool thing about having a trim, is that you can move any one of these guys around left to right, or maybe you have an object that might be scaled in like a very long stretch, aka like a trim, as in like how we use for crown molding or other things for other bits of geometry. You can do so as well. Like if I grab this guy and I just scale him like this, guess what? You can very easily, by just doing a simple unfold, so we go here, I'll unfold along the U, boom, becomes perfectly seamless, and it's going to repeat the textures over and over again because we're using a tileable trim texture. It allows you to just move these guys where they need to be. That way you can grab, say, something like him, and if I do detach, and maybe this guy could be like an archway for whatever I need it to be. So if I grab him and here, let me just quickly make a simple little cut right down the exact middle. Or maybe not. Let's try and grab it again. So here's where one is. Here's where the second one is. And guess what? Now I can grab this and let's bevel it so I can add some edge loops on the inside of this strip. So if I go into here to bevel, and I can add a ton of segments. Here, let's add like 30 segments or even 40. And if I adjust the fraction and like try and move him across the whole surface like that, now they're all equidistant. Guess what? I can grab this guy now and I can do a deform, nonlinear deform, bend. And then now I just need to move this guy just a little bit so that he's like kind of closer to the middle. And then let's start to bend the curvature. So he needs to be rotated. And as you can see, I can now bend him as much as I want to make a perfect 90 degrees. And that can allow me to create a nice archway for my bricks. Even though there's probably maybe a small little deformation on the sides, it allows me to take these trims and make something really cool and really useful out of this. Now, let's go backwards a little bit. Because you can always use this for other stuff too. Because in some cases, there's going to be some bricks that will have some very odd types of placement or types of movement, so you can always reuse this in different ways. You can have some insets of bricks, you can have some bricks stick out, you can have these for how you transition between the floors to the walls. There's many different options on how you want to approach this. Trims are definitely going to be very versatile, but again, you just got to make sure you plan ahead in how you approach creating a trim. But you can very easily take something like this and maybe turn create a wood-based one, and the wood-based one you can use for other types of type of paneling or types of middle trim or crown molding for other types of houses, whether it's a Victorian style house or something that's maybe not as fancy like mid-century modern. That's another one that I've also done for some of my other assets. But the one thing I wanted to show after this is my last little bit is how you can take this and make it a lot more complex when you need it to be. So let me just save this and jump into the scene that I've been working in. So I have a very large mid-century modern style scene that has, when I hide these and some of these other props, I have a ton of other modular pieces. I have different types of walls and doors that you can move around and you can snap to, and they will be perfectly seamless. They use the same 512 textile density, and they have their own other bits of tileables, so they use a lot of typical wood tileables. We have inside and outside trims. That way I can snap to the inside or outside of any little type of asset that I'm trying to go for. if I have a trim like this that uses planks like this, I can always grab one of the trims on here, like this guy, and I can snap him right to the front of him, and now he'll have similar planks where I need them to be. Or if I have a simple flat wall, I can snap that simple flat wall over here, and it'll be perfectly seamless where it needs to be. I even have other bits of trims over here. Like if I take the trim that I just made like this and move him over to this guy, I can grab him, snap him over, and he uses the same type of wood trim, even though he's not using it right now. This is another type of versatility on there. And all of these guys use the same thing. You have a 1x2. So here's my little character right here, 1x2. This is a 4x4. And these are all different 4x4 formations for different windows, for book nooks, for different areas. These guys are all 4x2s as well. These are 2x4s, so 2 meters wide by 4 meters. So if I grab the human character again and move him over here, as you can see, fits perfectly. Because God forbid if I have a doorway that might be a little bit too tall for a 2-meter wall, like this, you can see right here, this is where the seam is. Maybe I need to actually use something much larger, so you can do a 4-meter piece. And 4-meter walls typically are pretty good to, easily make it noticeable. So you can always just snap these guys together, make it easy. And then for like brick trim, you can always use something like this, where if you need to use certain types of brick versus others, you can do so as well. This is a very versatile, very easily thing to create using just some simple stuff. So for the most part, it's, again, however you want to approach modularity. It's up to you on if you want to do more organic based, if you're doing an interior or an exterior type of scene, if you want to do more hard surface based. Just look at your reference. Again, you can go into things like Photoshop and actually mask out all of these different areas. Just know that look for where the repetition is going to be the most. If you end up, say, having a rotunda that doesn't actually repeat itself more than once, then you can always just make it one time, essentially. You can also use tilables or your own baked assets. It's also a versatile thing as well, too. Just know that make sure you're using proper physical scale with a human scale reference. If you ever need a human scale reference character, you can always go into Unreal Engine and you can find either one of the, I believe, the first person characters, or there's also a third person mannequin. And these mannequins, you can typically go to the meshes, grab Manny or Quinn, or they usually have the old Unreal Engine 4 one too. You can just grab them and do an asset action and export them. When you can export them, it will export out with the proper dimensions. Again, 180 to 185 centimeters, and then bring them in to use for reference where you need to be. You can also use textile density reference as well. So make sure when you bring in these assets that you're keeping an eye on the proper textile density that you're working with. If you're doing 512 per meter, make sure you set that up. If you're doing 1024 per meter, make sure you set that up. Typically, I actually like to bring in every single one of my materials on one of these things just to see how they look. So I have things like varnished wood. I have certain types of brick as well. Right here. Well, here's herringbone. So here's another type of wood material to use. And where is the last one? There's another type of textile density. There we go. So using all of these different types of brick, wood, or whatever type of tile materials, bring them in as a scale and size reference so that you can make sure that you can keep things consistent. Again, going back to even our previous videos before, textile density is always key. That way you can always use tileable textures to keep things a lot more optimized. Again, using instances, aka reusing the same modular pieces over and over and over again, will allow your performance to not be hit by having one singular large one-off asset or making everything bespoke and unique every single time. You can use enough modular pieces with enough shader and other little bits of game dev trickery to actually make it feel unique without it being again, using bespoke assets. So that in the whole is modularity. If you guys have any questions, feel free to leave comments. I'm always around to answer wherever you need to, but thank you all so much and take care.